So we are doing a system of equations today. So this is like where you have multiple y equals mx plus b. I go through this part first here at the top just to show you what we're finding and why you're doing it. Just kind of remember this as you're working the problems algebraically of what we're doing. So the three different scenarios that you have here, and this is our goal, is to find the intersection point. So if you put two graphs on a line, these are the three scenarios that you can run into, but what we're looking for is the intersection point. The intersection point is the one point that falls on both lines. Okay, so like that is the one point that would work for both of these. If we're on a street or going through the red light, like that is the intersection. You're actually on both roads at that time. That's the one spot that's on both roads. So like that is what we're looking for. And this is like the intersection point is something that's really useful in real life, because if you have multiple graphs on a line, it tells you like different things, like, you know, cost and a profit. Like when that intersection point happens, that would be your break-even point. And you can start to see this. So like the intersection point is a very useful thing in real life to find. Because of that, remember this as we're solving this, as we come up with these, like you are finding the intersection point. That's the one point that is on both of these lines. The two weird scenarios are if they are parallel. The definition of parallel is that they never intersect. So obviously there's not an intersection point we can find on those if they never intersect. So when you get parallel lines, it ends up being no solution. And we'll go through those because they do kind of end up weird on those. But parallel lines actually have the same slope. So you can kind of identify it as you're looking at it real quick. If they have the same slope, they're going to be parallel, which means the answer is going to be no solution. The really weird one, and let me change. I know y'all are writing, but probably haven't got that far yet. Oh, no. I didn't know the way Alex worded it a second ago. All right, so the other one that's super weird is just like this scenario right here. Like you may have the equation in y equals mx plus b, and then the other equation in standard form, the ax plus by equals c. So you may not recognize it at first, but if you actually graph the same line on top of each other, you graph one line and then you graph the other one, and it ends up going right on top. It ends up being the same line, which means there's an infinite amount of intersections, right? Because you're doing the same line. So the answer they have is infinitely many, because any point that works on one line is going to work on the other line. And it creates an infinite amount because you can do all the fractions and all that kind of thing. So it is possible that you don't recognize that you have the same line when you're working these, and then the answer is infinitely many. But we'll kind of go through those weird scenarios there. So just kind of remember, like I said, as we're going through these, that you are looking for the intersection point. All right, so the first topic that they talk about is just to check to see if these points are intersection points. So this is what a system of equation looks like. You have two equations, you're putting them on the same graph, and it's just having you check some of these points to see if they are intersections. So remember, this is like your x and this is your y. What we have to do is plug them into both of them, and they both have to work for them to be intersections, okay? So if I plug it into the top one, my y is -2, my x is -2, minus 8. So we're saying, does this equal? So that's -2 equals 6 minus 8. So -2 does equal -2. So that means that point is on my top line, okay? That point is on my top line. But then you got to plug it into the bottom one too to see if it works. So -2 for x, -2 for y. Does that one work? That would be 10 minus 6 equals, wait, 10 minus 8. How about that? Oh, let me turn off. Maybe if I multiplied right, 2 times 4 is 8. 4 times -8, okay. 2 equals 2, so that one works. So this one is on both of these lines. So yeah, it's on the top line, it's on the bottom line. So the only point that could be is the intersection. The only point that they would share would be the intersection. So you can check a point to see if it works for the intersection. It does have to work for both of them. So like if I do this one again, or do part B here, y is 1, x is -3. So I get 1 equals 9 minus 8, so 1 equals 1. So that means it is on the top line, right? That works. 1 equals 1, so it is on the top line. But when I plug it into the second one, the bottom one, so I get 15 plus 4 equals 2. 19 does not equal 2, right? So this one, that point is on the top line, but it's not on the bottom line. So that means it's not the intersection point. It would just be somewhere on the other line and not the bottom one there. All right, so this topic is just checking to see if the points are intersection points. The next topic, I think I need to go pull a problem real quick here because I don't know. If I make a problem off the top of my head. Oh, this one we can probably just do. Okay, so like there's an example of a parallel lines. So this one would be no solution. You don't really have to write that down, but they don't ever intersect, so it's no solution. This one right here, you would just look at the intersection. So it has exactly one solution. It would be -2 right there. I probably won't spend too much time on that because y'all can read the graph. And then this one right here, yeah, you can see line 1 and line 2 right there, line 2 and line 1. So they are on top of each other. Those are actually end up being the same exact line, so it has infinitely many. Okay, so that one you're just looking at it and deciding if it has an intersection point or not. There are, to do these system of equations and find that intersection point, there are 3 different ways to do it. When I teach, I try not to show you a bunch of different ways because I just want you to do it the easiest way, okay? But unfortunately on this one, it's kind of easy when it looks one way and easier when it looks like you really will use 2 of them. But the first way to do this, I didn't even look at that. -x minus 1. -2x minus 5. Okay, so the first way to solve these is to graph it. This does not work great because, well, it really doesn't work great for me because the handwriting, like it is hard to do this on paper. On a computer, it's super easy because like everything's lined up perfectly and all that kind of thing. But when we graph this, it's kind of hard to tell where the intersection is. But this is a good refresher over what we did on Tuesday anyway, so I wanted to do it. And we'll see if we can write pretty enough that our answer will come up and we can tell where it is. So on the top line, we'll make this one our blue one. My slope is -1. So remember that's -1 over 1. Negative, so we go down. The bottom number, we always go to the right. And then my y-intercept is at -1. So I start at -1, and then I'm going to go down 1 to the right 1. Okay. So that's my top line. The bottom line, we'll make red, is -2. So that's -2 over 1. So that would be down 2 to the right 1. And my y-intercept is -5. So I start at -5. 1, 2, 3, 4, 5. Oh, and it's -2. So I go start at -5. And I go down 2 to the right 1. This I'm not going to be able to tell. See, this is why graphing it by hand does not work well. Oh, man. Sorry. Let's get the answer here. I can click the answer. So, yeah, when you graph it on a computer, it's very easy to tell. But when I'm doing it by hand, my intersection point is going to be somewhere over here. The answer ends up being, what, -4, 3. So this is why we don't do this one that much. There's only one topic on this one. But it's hard to do when you do it by hand because we don't space everything out perfectly. On the computer, it's really easy to do, though. So that's a good refresher over some of the problems we did on Tuesday. But this is the first way to solve these. And like I said, it's kind of hard to do by hand because we don't space everything out perfectly. But on the computer, when y'all do it on Alex, it is pretty easy there. There's one other topic I needed to look at here. Where's it at? Week 2. Oh, yeah, this one. So this kind of ties into what we did last week, too. Wait, maybe I have one. Sorry, I have one right here. So this topic is you are going to write the equations out. It really doesn't have to do with the intersections. It's more about like reading the graph and finding the different ones. It doesn't matter which one you put first or second. Well, we didn't do this the other day, so I figured I'd hit it real quick. So when you write an equation, the easiest thing to do is just put it in y equals mx plus b and find the slope and the y-intercept. So I'll do this one first. My y-intercept is going to be 7, all right? And then what you want to do is work towards the other point. So on this one, to get to this point right here, the intersection point, I'm going to go down 1, so that's -1. To the right, 1, 2, 3, 4. So that would be -1/4 x plus 7, okay? You always want to work to the right. Find the y-intercept and then work to the right. Okay, if you work to the left, you got to do things backwards. Always work to the right. And then the other one, my y-intercept is at -2. You can find a point that's quicker right here like this. Like that is a point because it's on the corner of these like dotted lines right here. But the easiest thing to do is just work to a point that you know for sure. So 1, 2, 3, 4, 5, 6, 7, 8. So I went up 8, so it's positive. To the right, 1, 2, 3, 4. Okay. So it is 8/4, right? You go up first and then to the right. 8/4, so that would be 2. 8 divided by 4 is 2. So that means I could actually just go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Okay. But it's easier when you're reading a graph just to go ahead and find a clear point, and then you can simplify it just so you don't get mixed up on trying to find a point on that line. So this one, you're just writing the equations out from a graph. And obviously, we can tell the intersection point here is, what, 4, 6? All right, let's get into the algebra part. So graphing it, you can graph it and find the intersection. I mean, computer math and, Desmos and things like that makes it super easy. But the first algebra way to do this, and on Alex, it will have topics on these different ways, so the explanation will be like that. But technically, you can do it either way that you want to. Like I said, I try to only pick one way to do things and then do that the whole way. But on this one, unfortunately, it's a little easier to use substitution in some scenarios and then the other way in the different scenarios. So it is easier to use substitution when you have a variable already by itself. Okay. I already have the y by itself, so it's easier to use substitution. What substitution does is we say that y equals 2x plus 8. So y equals all of this, okay? Y equals all of this. So what I'm going to do is I'm going to substitute that into the other equation. Instead of writing y, I'm going to write what y equals. So I'm going to rewrite the second equation, 5x minus 4, and instead of writing y, I'm going to write what y equals, and it equals 2x plus 8. Okay? So you substitute it into the other one. That's why this is easier when you already have one solved for. Like if the y wasn't by itself, we'd have to solve for y. But we are going to take what y equals and plug in, instead of writing y in the second equation, write what y equals. So we put that 2x plus 8 in for the y, and now we have an equation with all x's in it, and we can solve it. Distribute the -4. You got to be careful when you distribute the negative. Make sure you distribute the negative. That is all one number right there. So -4 times 2x is -8x. -4 times 8 would be -32. And now combine like terms on the left side. So that would be -3x. I can't do any more combining because this has an x and this doesn't. So I'm going to add 32 to both sides. It's +9. And then to get x completely by itself, I divide both sides by 3 and get -3. All right, that's the hard part. Once you get one answer, I'll write it in all caps here. Once you get one, plug it back in. Okay? Once you have one answer, all you got to do is plug it back in. So the goal is to get one answer. You can plug it into, actually you can plug it into the top or the bottom and figure out what the y is. On substitution, it's always easier to plug it into like the one where it already has it solved. So if I plug that x into the top, I'd get 2 times -3 plus 8 equals y. And then just solve that to figure out what y is. So once you get one, you just plug it back in to find the other one. And this is, don't forget, like this is our intersection point. This is a 1 point that is on both of those lines, so that is where these two lines intersect. All right, so substitution is easier when a variable is all by itself. I think we'll do that one more time, just to kind of show you the difference here. But on this one, the x is already by itself. It means to use substitution. Okay. So since the x is already by itself, this time we're going to take what x is equal to and plug it into the x here. Plug it into the x in the other equation. Okay, so I rewrite the second equation. Instead of writing x, I'm going to write what x is equal to, and it's equal to 3y minus 12 minus 5y equals negative 16. Now, I did this problem mostly to show you that it doesn't matter if you're solving like the x is equal to something, or the x is by itself, or the y is by itself. You still can just substitute it in. When we move to the next thing, it's the same thing. You just choose whichever one's easier to solve for first. All right, so we distribute here, and you get 9y minus 36 minus 5y equals negative 16. You can combine like terms. Oops. My mother overriding do not disturb. 9y minus 5y would be 4y. Now we've combined all of the things that we can. This has a y, this one doesn't. Add 36 to both sides. So I get 4y equals 20. Divide by 4, and y is equal to 5. Again, like before, once you get one answer, all you got to do is plug it back in. It's easier to plug it back into the top one, so I plug a 5 in for my y. 15 minus 12 is 3. So these intersect at the point 3, 5. All right, so substitution way is easier when a variable is already solved for. And when you're doing this topic, I think I saw this last class. Let me just go check real quick. So like that one already has a y by itself. This one like doesn't have a y by itself, okay? What you could do on this one is add that 2y over. So you could add the 2y over and make x be by itself pretty easily, okay? But when they're in this form, I actually like to use the other method. And, you know, Alex doesn't know how you're working out the problems. The explanation is going to look like that. But the other method is called elimination or addition method. I like this way better. It just makes more sense in my brain. I think it's easier, probably less writing. So the elimination method or the addition method, what we are going to do is we are going to add up the equations and see if something cancels out for us. So on this first one, we're just going to add these up. 5x plus 2x is 7x. And then 3y plus negative 3y, those cancel out, right? So negative 3 plus 24 is 21. Well, by adding these equations up, it made the y's cancel out, and now I just have this really easy equation, 7x equals 21, divide by 7, and x equals 3. Okay? So if you can add them up and a variable cancels out, then it makes it super easy to do. And like before, once you get one answer, you plug it back in. It does not matter which one you plug it into. I think I'm going to plug it into the top one. 3 in for x. We got to solve for y. So that's 15 plus 3y equals negative 3. Subtract 15 from both sides. And 3y equals negative 18. Divide by 3 is -6. So these intersect at the point 3, -6. I feel like I'll go ahead and say this here and give you a chance to write. Alex is very good about not giving you fractions on these problems, okay? So it's kind of like an easy indicator to tell that you added or messed up a sign or wrote it down wrong or something like that. Always make sure you write down these correct, double check, because it is easy to write it down from computer to paper wrong, and then you do this whole problem and miss it. But if you get a fraction on one of these, it probably means you messed up something simple. Go back and check your work. All right, the next one. Don't write this part yet. When I go to add these up, I get 10x plus 10y equals 30. Well, that doesn't work, does it? Because now a variable didn't cancel out. So no variable canceled out on this one. So what we need to do, that's the part I didn't want you to write down. You can write down stuff now. What we need to do is manipulate this equation so that when I add them up, something cancels out, okay? So the variable that looks easy to cancel out here is the y, because they're both 5s. So what do I add to positive 5y to make it be 0? -5, right? So I need to turn one of these into a -5. So the way I'm going to do that is I'm going to multiply one of them by -1. You have to multiply the entire equation by -1 to keep it the same. So -1 times 3x would be -3x. -1 times 5y would be -5y. -1 times 5 would be -5. So I did not change the equation at all. I just multiplied it all by -1. So make sure you multiply all three things by -1. It's very common to forget to multiply this last one just because it's over there by itself. So make sure you multiply all three things, all of it, by -1. And now let's go through that step. Let's add these up. 7x minus or plus -3x would be 4x. Those cancel out. 25 plus -5 would be 20. So we may have to manipulate the equation so that when we add them up, they cancel out. So I'm going to divide both sides by 4, and x equals 5. And then just like before, once you get one, you can plug it back in. Technically, you could plug it into any of those three and it would work because this equation and this equation are the same, right? So I don't know, plug it into the top one because it's got smaller numbers. But if you plugged it into the bottom one, you would get the same thing as me. So that's 15 plus 5y equals 5. Subtract 15 from both sides. And divide by 5. A little red mark there. That's a -2. So these intersect at the point 5, -2. All right, this next one, which variable looks like it's easy to cancel out? The y's, right? Because I could just multiply the bottom one by 2. And that would be 6x minus 4y equals 24. Okay, we're multiplying it by 2 to make this be positive and -4. And now when I go add these up, I'm going to cross through that just because I don't want to get confused there. 7x plus 6x would be 13x. 4y, -4y cancel out. -24 plus 24 is 0. That is fine that that's a 0. 0 is just a number. So we continue just like we're supposed to. So divide both sides by 13. 0 divided by anything is 0. So now once you get one, the the hard part's done. You just plug that 0 in. So I'm going to plug it into, the top one. It doesn't matter. I'll do the top one just because it's not crossed out. Why is my iPad got a delay? Okay. So 7 times 0 is 0. So you just have 4y equals negative 24. Divide both sides by 4, and y is negative 6. So these intersect at the point 0, negative 6. All right. So we have multiplied like one equation to make it manipulate and cancel it out. On this problem right here, by just glancing at it, which variable looks easier to cancel out? I think they said x the last class too. 6 and 9, yeah, okay, so what numbers could I make 6 and 9 add up to be to cancel out? What do you say? It's got to be higher, yeah. We got to go higher to be able to multiply. 18, right? If she chooses to do the x's and he chooses to do the y's, that's fine. You'll still get the same answer, okay? So the y's, you can make them be 14, right? And one's positive and one's negative, so we don't have to worry about that here. So if we want to make these be 18, and I'll go through my little spiel real quick. We want one to be positive 18 and one to be negative 18, okay? This, I told you in class, like most of this has to do with real life math. The algebra one's the hardest one to relate to. The reason you have to take math class, and will you ever use this in real life? The answer is no. Probably the only math professor that'll tell you that. But the reason we have to do things like this is because of the thought process and the problem solving skills. So like in real life, everybody's going to have a problem, right? Like somebody at times going to have a problem. When I look at this problem, I have no idea what to do, right? You have a problem, you have no idea what to do. But let's just start breaking it down piece by piece. If I can do this piece, if I can do this piece, if I can do this piece and put it all together, then maybe I can solve the problem. So no matter what you do in life, even if you don't have a job or anything, like you will still have a problem that maybe you can't solve. But if I can do part of it here and part of it here and part of it here, maybe I can figure out how to solve it. All right. So we need it to be 18x and negative 18x. So we are going to multiply 6 by 3 to make it be 18x, right? 3 times 6x is 18x. 3 times negative 3 times negative 7y is negative 21y. 3 times negative 4 is negative 12. Make sure you multiply all of them. This is very common to forget to multiply that one. And then on the bottom, to get 9, or negative 9 to negative 18, I need to multiply by 2. So you may have to manipulate both equations to make it to something you can cancel out. 2 times negative 9x is negative 18x. 2 times 2y is 4y. And 2 times 23 is 46. Now when I add these up, my 18s cancel out, so we did good. We have negative 17y equals 34, even though we got strange numbers. Like I said, Alex is probably not going to give you fractions on these. So you'll know that she did it right or wrong. So now once you get one answer, you take it and plug it back in. I'll plug it into the bottom one. I don't know if I've plugged it into the bottom one yet, so why not? So that becomes, that becomes negative 4. Add 4 to both sides, and it's 27. Divide by negative 9, and y is negative 3. Oh, no, that's x, isn't it? Not y. So negative 3, negative 2 is the point of intersection of those two. All right. Oh, no, wait. We got to do one other thing before I say that. So there is one topic that kind of has those weird options on there. So on this one, as soon as I see it, when it's in this format, when I don't have to like have a y by itself or x by itself, I always do the elimination. So when I go to do the elimination one on this one, well, 5x plus negative 5x, those cancel out. But then negative y plus y, those cancel out as well. So I get 0 on this side. You still got to put a 0 because now there's nothing there. And then negative 9 plus 9 is also 0. So if you get down to this last thing and it cancels out, it is going to be true. Since that is true, that means they are the same line, so you have infinitely many solutions. Okay? Just to show you one real quick here. If I was doing one like this, and I added these up, well, negative 3x plus 3x cancel out. 5y minus 5y cancel out. But then 2 plus 10 is 12. Well, that's not true. If it is false, if you end up down there and it's not true, like if it's not 0 equals 0, it is going to be no solution. These lines are actually parallel. Okay. So that's how you tell the difference between no solution and the infinitely many solutions. This part B down here, we can go ahead and do it just because why not? It only takes a second. But when I add these up, my x's cancel out. 1 and negative 1. That becomes 6y equals 18. So like this is one that we can solve just like we were doing. Divide by 6 and y equals 3. Once you get 1, go plug it in. X plus, I'll plug it into the top one. That's x plus 9 equals 13 and x equals 4. So my answer here would be 4 and 3. It would be this one. Oh no, I moved my little... I messed that all up, didn't I? The picture started doing something differently when I screenshotted it last class. Okay, so yeah, this topic, they should be pretty easy to solve, but you're going to run into those 3 different scenarios where if both of them cancel out and it's 0 equals 0, then it's infinitely many solutions. But if both of them cancel out and it's like 0 equals 12, then it is no solution. And then, of course, you can get the one solution like we have been doing. All right. Last couple problems here. This one ends in word problems. We have not done word problems in this class. I always will try to do, one word problem or so, but if there's like a pattern to it, then I can like really help you with it. But when you like the word problems don't have a pattern to it, then it makes it harder for me to teach because then I just need to do like 12 of them and we don't got time to do like 12 of them, do we? These do have a pretty good pattern to it, but if you ever need help with the word problem, like those are the ones you can say, like we finished early the other day, we'll finish early most days. If you need to say, hey, can you help me on that word problem or help me on that problem, like you can send it to me before class. You can just tell me to do it in class. You can even tell me to just pull up what you're working on last night, and we can look at it real quick to figure out which one you were struggling with. It's always easier if you just send it to me, though. But with the word problems, I try to make them. If there is a way to solve them without using algebra, I do that. I try to do that with you. Okay, so like this one, you could maybe guess and check, but it would take a long time. This one's not too hard, not too bad though. Or these 2 word problems aren't too bad. Just first word problems, so I figured I'd talk about it. All right. A textbook company store sold a combined total of 372 math and psychology textbooks in a week. The number of math textbooks sold was 3 times the number of psychology textbooks. How many of each type were sold? So let's make math be X and psychology be Y. The first thing is it's combined to 372. So that would be X plus Y equals 372. If I add up the total amount that they both sold, it would be 372. Okay. The next thing would be the number of math was 3 times the number of psychology. Okay, I had to think about this in the first class for a second. So math is going to equal 3 times the number of psychology. It's kind of easy to see when you say math times 3 times to do this, right? But take 2 seconds and think about it. If I sell 10 psychology books, that means math would have 30. So that would be 3 times the amount. Math would have 3 times more than that, right? Whereas if you did it this way, you'd plug the 10 in here, you'd have 30 psychology and 10 math, okay? So take 2 seconds to think about it, plug in a number to make sure you got it right. But math is equal to 3 times psychology, actually. And I guess if you read the sentence, sold was 3 times the number of psychology. So that tells you right there. All right. On this one, technically you already have the X by itself, so it's easier to use substitution. So I'm going to take this X and plug it in. Oh, whoops, I don't want to plug that in. I want to plug this in. I'm going to, instead of writing X, I'm going to plug in the 3Y. So I get 3Y for my X, because X is equal to 3Y, plus Y equals 372. So there is a 1Y right here, so that becomes 4Y equals 372. Divide by 4, and Y is equal to, I think it's 188, but let me just double check. 93, oh, the other one. 93, so we have 93 psychology textbooks. Just like before, once you get one, plug it in. On the substitution, it's always easier to plug in. So we take that times 3, and it is 279. And you could double check this on a test or something. 279 plus 93, that does equal 372. So everything should be good there. 279 divided by 3 would be 93. You can kind of double check. So on that one, you kind of have to come up with your own equations there. That does make it a little tougher. They should be not too bad to come up with, because it does say basic relationship, so we don't have to do anything too crazy there. On the other word problem, they give you a chart. So here, a party rental company has chairs and tables to rent. There were two customers who rented both chairs and tables last week. The table below shows the number of chairs, the number of tables, and the total cost for these 2 customers, okay? So write the equation for those. Pay attention to this. That's a very large highlight. Pay attention to that because that tells you X is going to be chair and then Y is going to be tables, okay? So we start with the first one. I'm going to write it up here so I have more room, but you have 12 customers times the cost of the chairs, plus that first customer bought 2 tables times the cost of the tables, and it equals 35, okay? I believe, if I remember correctly from last semester, a lot of times you just transpose these tables, and it will be like that. It'll be like 12x plus 2y equals 35, okay? You don't want to go this way, though, because 1, you don't have 3 numbers, and 2, those are both x's, right? So we know this is x, this is y, and that's the total amount they spent. So really, it's just like transposing these tables. So again, with these tables, it does make it a little easier to come up with your equation. So the second customer would be 3x, 5 tables at the table price, and they spent 47. Oh, no. Can't do that. Okay. So now we have our equations. We just got to continue to do what we were doing. What variable looks easy to cancel out? X. What can I multiply? Or which one do I multiply by what to get it to cancel out? We have 12x here, so we need to get a negative 12x. So we want to multiply this one by negative 4. So negative 4 times 3x is negative 12x. Negative 4 times 5y would be negative 20y. Negative 4 times that, there's my negative 188. I knew that number was coming. 47 times 4. Now we want to add up the first and the third one there. Just crossing that out just so I don't accidentally add it. 12x plus negative 12x cancels out. 2 plus negative 20 would be negative 18y. 35 minus 188 would be 153, negative 153. Now I just divide both sides, by negative 18. And I get y equals, I said no fractions, but on this money one, they're going to give you an easy fraction like a quarter or 2 quarters here. Okay. And then once you get that one, just take it and plug it in. Plug it into the top one. 12x plus 2 times 850 equals 35. So that's 12x plus 17 equals 35. Subtract 17 from both sides. 12x equals 18. Divide by 12. And x equals $1.50. So it's $1.50 per chair and $8.50 per table. All right, so yeah, you won't get fractions on the other problems, but on the word problems, like when it talks about money, you may get some decimals like that, but they should be clean decimals. If you get like 731, like it's probably not right. I think y'all can let me know if that's wrong.